Hello, CSEC students. Welcome back to another live CSEC class. This morning we're continuing our look at matrices, and we're going to be looking at the inverse of a 2x2 matrix. The last matrices class that we did, we said that in order to find the inverse of a matrix, you need to find the determinant and you need to find the adjoint. So we did that. We learned how to find the determinant, how to find the adjoint, and now we're going to combine those to find the inverse of the matrix. I want to welcome those who are joining the class from anywhere in the universe you are, joining that class from Facebook, from Twitter, from YouTube. All right, so welcome to those in the chat, and we're going to get started now. All right, so this is finding the inverse of a 2x2 matrix and the formula for that. So let's say we have matrix A, and we're going to call that A, B, C, D. So these are the general letters we give to the matrix, right? A, B, C, D. So to find the inverse of A, which we write as A to the -1, the inverse of A would be 1 over the determinant. So it's 1 over the determinant of A multiplied by the adjoint. And we learned to find these two things in last matrices class. If you need to remind yourself or give yourself more practice in finding the determinant, finding the adjoint, you can check out that video that was done, the last matrices video, or go to the playlist on the channel and you will see the matrices video. So we need to find the determinant, put 1 over it, and multiply that by the adjoint. So let's recap. The determinant of A would be A times D minus B times C. And the adjoint would be we're going to switch places with the A and D. So the D comes here, the A goes there, and we're going to change the sign of the B and C. So to find the inverse, we'd multiply 1 over the determinant times the adjoint. So let's say we're given matrix B, and that matrix is 6, 3, -1, and 4. So to find the inverse of B, we need to first find the determinant of B and the adjoint of B. So the determinant of B would be A times D, so 6 times 4, 6 times 4 minus 3 times negative 1 and that's going to give 24. So this negative will work with this negative multiplying it, so we'll get a positive 3 and that's going to give us 27. So the determinant, so it's 1 over the determinant, right? So 1 over 27. Now to find the adjoint, that would be, we're going to switch places. So the 6 and the 4 switch places. And we're going to change the sign of the 3 and negative 1. So it's going to become negative 3. And the negative 1 is going to become positive 1. So we're multiplying now that by 1 over the determinant. So each term here, we're going to multiply by 1 over 27. So the final answer for this then, so that will be equal to 1 over 27 times 4 is 4 over 27. 1 over 27 times negative 3, the negative 3 cancel the 27, so that's negative 3 into 27 goes 9 times, so negative 1 over 9. And 1 over 27 times 1 is the same, 1 over 27. And times 6, it will be 6 over 27, which cancels to 3 into 6, 2, 3 into 7, 27, 9. Okay, positive. So this is the inverse of B. So we would put, so on your page, you would do it step by step to show. I'm using limited space, so I'm all over the place, so bear with me. So that's the inverse of B, 4 over 27, negative 1 over 9, 1 over 27, and 2 over 9. We'd close that bracket. I don't have space to close my bracket there. So have a look at it from the top and tell me if you understand. All right, so welcome. I'm seeing Jamani, I'm seeing Imani, I'm seeing Alicia. Alicia says, Miss, I like your videos. Thank you so much, Alicia. I like your company. And please don't hesitate to drop your comments, your answers, so that we can compare and see how everybody is doing. I'm seeing Ngozi, so welcome to everybody. So what we did, so we were given matrix B. Okay, also seeing Michaelia. We were given matrix B, and it is 6, 3, negative 1, 4. And we were asked to find the inverse of that matrix. So we know that in order to find the inverse, we have to find the determinant, put 1 over it, find the adjoint, and multiply. So 1 over the determinant times the adjoint. And we did that, and we ended up with the inverse. So let's do a couple more for practice. All right, so let's say matrix C, and matrix C is 4, -6, 8, -2, and we're asked to find the inverse of C, so C to the -1. We know that to find the inverse, we need the determinant and we need the adjoint. So the determinant of C would be 4 times -2 minus -6 times 8. And that gives 4 times -2 is -8. Negative times negative is positive, 6 8 48. -8 plus 48 would give a positive 40. So that's the determinant. And the adjoint would be A times D. So 4, sorry, the adjoint, we switch places. I'm sorry. So switch places, switch the A and the D. So don't change the sign of the A and D, just switch them. So we'd have -2 there, and the 4 goes down where D was. Now the B and the C, we change the signs. So the -6 is going to become +6, and the 8, +8, will be -8. So if we move these two, if we switch them, we reverse places, exchange places. But the B and the C, we don't move them, but we change the sign. So the inverse of C would be 1 over the determinant times the adjoint All right, so each of these terms in the bracket, we're going to multiply by the 1 over 40. So 1 over 40 times -2 would give -2 over 40, which cancels to give -1 over 20. 1 over 40 times 6 would give 6 over 40, which cancels to give 3. So 26, 3, and 2 into 40 goes 20. 1 over 40 times -8 would give -8 over 40. And when we reduce that, we get -1 over 5. 8 into 40 goes 5 times. 1 over 40 times 4 would give 4 over 40, which is reduced to 4 into 4, 1, 4 into 40, 10. So that's our inverse. That's the inverse of matrix C. All right, so if it was not clear to you, is it any clearer now? All right, so Carissa is here. Philip is here. Philip, are you sure you should be in this session? All right, so give me some feedback. We're going to do maybe 4 more for good practice, right? Just to make sure we have it down pat. All right, because as simple as it is, if you don't practice it, Imani is saying, yes, miss, I understand. Very good. I love to hear when students say they understand. And I love when they mean it. So if there's anything at all you're not getting, I want you to let me know, and I'll gladly go over that step for you. We're going to do about 4 more. Make sure you practice. Yes, Carissa, we're going to do about 4 more, maybe even 5 more for good measure. Can't be too many. All right, so let's go again. So it's 1 over the determinant times the adjoint. So let's say matrix D, and that is, so let's say -12, 0, 6, 4. And we're asked to find the inverse of D. So that's D to the negative 1. That's how we write it. So we know that it's going to be 1 over the determinant times the adjoint. The determinant of D would be A times D. So that's negative 12 times 6 minus B times C. So that's 0 times 4. And that's going to give negative 12 times 6, that's negative 72. And we know 0 times anything is 0. So that's negative 72. The adjoint would be to switch places with the A and D. So we don't change the sign of the A and D, we just switch places. So the 6 would come here and the negative 12 would go there. For the B and C, we're going to change the sign. So 0 is 0. There's no negative or positive 0, it's just 0. The positive 4, we're going to change that to negative 4. So we have our determinant, we have our adjoint, and we know that the inverse is 1 over the determinant times the adjoint. So it's 1 over, so negative 1 over 72 times the adjoint, which is 60, negative 4, negative 12. And that gives us, so negative 1 over 72 times 6 would give negative 6 over 72. And we know that's going to cancel. All right, so that's going to cancel to negative 1 over 12. Negative 1 over 72 times 0, we know that's going to give 0. And negative 1 over 72 times negative 4 is going to give a positive 4 over 72. And 4 into 4, 1. 4 into 72 goes 18. Negative 1 over 72 times negative 12 will give a positive 12 over 72. And 12 into 12, 1. 12 into 72, 6. So that's positive 1/6. And that is our inverse of matrix D. Okay? So we're going to do 4 more. And the more we do it, the better you get. So Ngozi is asking, what is the meaning of the negative 1 beside the C? So the negative 1 at the upper right-hand corner is our way of writing the inverse. So you raise it to the negative 1 power. It's the same as 1 over whatever you're raising. So that's the inverse of the matrix. That's how we write it. All right, so let's continue. Matrix E. So let's say matrix E is negative 5. Let's make them all negative. So negative 5, negative 8, negative 4, negative 15. So the determinant of E would be A times D, so negative 5 times negative 15 minus B times C, negative 8 times negative 4. And that's going to give negative 5 times negative 15 is a positive 75. Negative 8 times negative 4 is a positive 32, and we have a minus sign there. So this is going to give, so 75 minus 32, and that's 43. The adjoint, for the adjoint, we switch places with the A and D. So the negative 15 would come here. The negative 5 would go there. And we change the sign of the B and C. So the negative 8 will become a positive 8. We don't move it. We just change the sign for the B and C. The negative 4 would become a positive 4. So the inverse of E, so E to the negative 1, would be 1 over the determinant. So 1 over 43 times negative 15, 8, 4, and negative 5. Which gives, so 1 over 43 times negative 15, that's negative 15 over 43, which cannot be reduced. 1 over 43 times 8 is 8 over 43, which cannot be reduced. 43 is prime. 1 over 43 times 4 is 4 over 43. And 1 over 43 times negative 5 is negative 5 over 43. And this is our answer. We can't simplify these fractions since 43 is prime. So that's our answer there for the inverse of E. All right, so let's do F. So let's make them all positive now. So we have 20, 30, 18, and 9. The determinant of F would be A times D, so 20 times 9 minus 30 times 18. All right, so we know that 20 times 9 will give 180. All right, so 20 times 9, that's 180. And 30 times 18, that's 540. So 180 minus 540, that's negative 360. That is the determinant. The adjoint would be, now we're going to switch our places. So where A was, we put it down where D is now. And where D was, we put it up where A is. For the B and C, we change the sign. So it becomes negative 30 and negative 18. So for the inverse of F, that is 1 over the, so it's 1 over the determinant, so it's negative 1 over 360 times the adjoint, so 9, negative 30, negative 18, and 20, which gives, so negative 1 over 360 times 9 would give negative 9 over 360. And this cancels down. So 9 into 360 goes 40. So it's negative 1 over 40. And negative 1 over 360 times negative 30 will give a positive 30 over 360. And that cancels down. The zeros cancel. 3 into 36, so that's 12. So this is a positive 1 over 12. The negative 1 over 360 times negative 18 will give a positive 18 over 360, which reduces to 1 over 20. And negative 1 over 360 times positive 20 would give a negative 20 over 360. And that cancels to 1 over 18, negative 1 over 18. And that's the inverse of matrix F. All right, so we have what, about 2 more to go. That's the inverse of F. Let me check the chat to see if there are any questions or answers posted. All right, so everybody seems good. So we're going to do 2 more. So matrix G. So let's say G is 0, negative 11, negative 10, and another 0. Okay, what would we have here? So the determinant so A times D minus B times C, and that gives 0. Negative 11 times negative 10 is positive 110, and this here will make it negative. So the determinant is negative 110. The adjoint would be still 0, 0, positive 11, positive 10. The inverse of G would be negative 1 over 110 times 0, 0, 11, 10. And that gives, so we'd have, this would give 0. This would also give 0. And negative 1 over 10, 110 times 11 will give a negative 1 over 10. And negative 110 times 10 would give negative 1 over 11. Okay, so the last one, matrix H. Okay, so let me make sure I've done all the possible. So we've done all positives, all negatives, mix them up, put zeros, or maybe a fraction, no? All right, let's do a fraction. So H So let's say we have a half, 3/5, negative 1/3, and 8. So the determinant would be A times D, so half times 8 minus 3/5 times 1/3. And that gives half times 8 is 4. 3/5 times 1/3 is 1/5. And 4 minus 1/5, that would be 3 4/5. Okay, we know that that's 5 3 is 15 and 4, so that's 19/5 as an improper fraction. For the adjoint, we switch places. So we'd have the 8 here, the half there, the negative, so change the sign, the 3/5 becomes negative 3/5, and the negative 1/3 becomes positive 1/3. So the inverse of H, so that would be 19/5. Oh, it's the inverse one. So we need to it to be 1/19/5, which so we're going to reciprocate the 19/5. So it will be 5/19 times the adjoint. So 8 negative 3/5 1/3 and a half. And this would give, so 5/8 40/19, 5 3s 15, so that's negative 15, and 19 times 5, 5 9s 45, so that's 95. 5/19 times 1/3, so that's 5. 3 9s 27, that's 57. And times a half would be 5/38. So the only thing here that can be reduced will be the negative 15/95. And for the matrices, you are allowed to leave your final answer as improper fraction. You can do that. So that would be negative 1/19. And we have to write back the other 3, the other 2, they cannot be reduced. All right, so 5/38. So just remember, if you end up with a fraction as the determinant, since it would be 1 over the determinant, so you would just reciprocate it. Reciprocate the fraction and multiply by the adjoint. All right. So let me know if there are any questions. All right, so that's it for the inverse of a 2x2 matrix. So remember the 2x2 matrix, 2 rows, 2 columns. All right, so Jada Karsa is saying, I understand, which is awesome. All right, so hopefully everybody understands. And the next time we do matrices, we'll decide if we have to do some more of this or go on to using the inverse of the matrix to solve simultaneous equations.